Hi students, in this video we are going to study about Pascal's law. Now Pascal's law is a law which explains how pressure is transmitted in a fluid. If you are applying pressure to a particular point in a fluid, what happens to the pressure? How is it transmitted throughout the fluid? Imagine you have a balloon with you, okay? And this balloon is filled with water. And you prick the balloon here and there. Suppose, okay, this is my balloon. I am filling the balloon with water and I am pricking the balloon here and there with a needle. And so definitely water will be flowing out through those holes. Now if suppose I am applying force at a particular point in the balloon, which means force per area is pressure. So if I am applying pressure to a particular point in the balloon, my question is, will the water coming through the holes near to the point of application of pressure will increase, means speed will increase, or if I am applying pressure to this particular point, will the water coming out of all the holes in the balloon will be flowing with the same speed? Means is it coming out throughout the balloon? Is the fluid coming out flows with the same pressure, comes out with the same pressure? Definitely the answer is yes. You are applying force to a particular point in the fluid or in the water, in a case of balloon, but that pressure is getting transmitted equally in all directions throughout the liquid present inside the balloon, and as a result the fluid water which is coming out through the holes will be coming out with the same pressure or with the same speed, we can say. So the pressure applied to one point is transmitted equally in all directions. And this is what Pascal said about pressure which is being exerted to a fluid. Now, according to Pascal's law, the pressure exerted at any point in an enclosed fluid, at any point you apply, it is transmitted equally in all directions. The pressure which is applied at any point in an enclosed fluid will be transmitted equally in all directions. And this is what Pascal's law states. Now Pascal's law has two important applications. First one is the hydraulic lift and second one is hydraulic brake, and both these you must have seen somewhere. So first one is our hydraulic lift. If you have gone to a car washing area and all, you must have seen an hydraulic lift there. Now hydraulic lift is used to lift heavy objects. To lift very heavy objects, we use a hydraulic lift which is based on the principle of Pascal's law, which works on the principle of Pascal's law. Now, hydraulic lift basically consists of two cylinders, two cylinders of different cross-sectional area which is connected to each other with the help of a tube. We have two cylinders of different area. Area of the first cylinder is A and second one of the cylinder is capital A, and they are connected with the help of a tube, and this arrangement is filled with the fluid. Now, to both the ends of the cylinders, a movable frictionless piston is connected. You know what is a piston, isn't it? It moves up and down. This movable frictionless piston. So the parts of a hydraulic lift are two cylinders of different area. In our case it is small letter a and capital letter A, connected to each other with a tube and is filled with the fluid. Now, the other main important part in the case of a hydraulic lift is it consists of frictionless movable piston. Now when we are applying force, because there is less friction, the piston will be moving up and down depending upon the direction in which the force is being applied. Now the basic working of a hydraulic lift is, now imagine I am applying a force F, amount of force F on this side of the piston. So force applied to an area is what we call pressure. So pressure is being acting on this side of the piston and the piston moves down. Now according to Pascal's law, this pressure is being transmitted to the fluid inside the cylinder, and according to Pascal's law, the pressure will be transmitted equally in all directions. And as a result, because of the pressure, the piston on the other side will move up with the force capital letter F. Okay? And we will find that this force will be greater. The force with which the piston moves up on the other side of the piston will be definitely greater than the one which we has the amount of force which we have applied to this side of the piston. And hence we will be using this principle, we will be able to lift heavy objects. Okay? So let small letter f be the force applied on piston having area A. Then the having area A. Then the pressure exerted on the side will be F is equal to F divided by A. Now, according to Pascal's law, pressure will be transmitted in all directions, and as a result the piston on the other side moves up with a force given by F is equal to, force is equal to pressure into area. So this we can write as F by A into A. Or rearrange we can write F into capital A divided by small letter a. Now, if you look into this diagram, it is definitely clear that capital A is very much large than small letter a. So, definitely the term F by A will be large. Since capital A is very much big than small letter a, the term A by A will be also large. Hence, the force with which the piston on the side having area capital A will be more than small letter f, that is force exerted on the other side of the cylinder or the other cylinder, and we can move or lift heavy objects using this. Hydraulic lift means a device used to lift heavy objects, and it is based on the principle of Pascal law. It mainly consists of a small cylinder having area small letter a and a large cylinder having area capital letter A, which is connected with the help of a tube, and this arrangement is filled with the fluid, and we apply a small amount of force to the smaller piston, and with this force of this pressure is transmitted to throughout the fluid, and the second piston moves with a larger force, and that force the object can be lifted, and this is how a hydraulic lift works. Now next, let us see what is the second application of Pascal's law, that is hydraulic brake. Now the hydraulic brake mainly consists of a tube. It consists of a tube, okay, which is filled with a fluid, the brake fluid. And one end of the tube consists of a master cylinder. This is the master cylinder. And this cylinder consists of a piston P. Now, this piston is connected to the brake pedal, the one which your parents used to put brake, with the help of a lever system. And the other end of the tube is connected to a wheel cylinder. This much is a wheel cylinder. This is the wheel cylinder. Okay. And this wheel cylinder consists of two pistons P2 and P1. And this piston is connected to two brushes which we call the brake shoe. Okay. So, the parts of a hydraulic brake is, first one, a tube filled with an oil. Second one, the one end of the tube is connected to a master cylinder which has a piston P, okay, connected to the brake pedal with the help of a lever, and other end consists of a wheel cylinder which is consisting of pistons P1 and P2, which is connected to the brake shoe. S1 and S2. Now let us see what is the action, or how does a hydraulic brake works. Now when you apply force to the brake pedal, when you apply force to the brake pedal, what happens is that the piston P moves inward. So the pressure is exerted to the fluid present in the tube, and this pressure, according to Pascal's law, is transmitted throughout the tube where the fluid is filled. So this pressure is exerted to the wheel cylinder also. Now what happens is that when this pressure goes to the wheel cylinder, the two pistons P2 and P1, it will go outward, it will move outward, it will get separated. And the shoe brakes, which is connected to the piston, will go and touch the rim of the wheel, which prevents or retards the motion of the vehicle. This is how the brake acts. Now what happens once you remove your foot from the brake pedal, the pressure or the force exerted is gone. So the pistons will try to come back to its initial position, and because of the action of the spring present in the wheel cylinder, the brake shoes will come back to its initial position, and then the vehicle will start to move. Very simple working. So what happens? What happens? First, the pressure is applied on the brake pedal. That brake pedal will move the piston inward of the master cylinder, and this pressure is transmitted equally in all directions, and it will be transmitted to the wheel cylinder of one wheel. This pressure makes the piston P1 and P2 move outward, and as a result the brake shoe, which is connected to the cylinders, to the piston, will go and touch the rim of the wheel, and they retard the motion of the vehicle, and the vehicle will stop. Now once the pressure from the pedal is removed, the brake pedal is removed, because of the spring action, the brake shoes will come back to its initial position and thus make the vehicle move forward. Now this tube is connected to other sides of the vehicle wheel, So the pressure is getting transmitted equally in all the direction, and hence then the brake system will work. Now the advantage of hydraulic brake is the master cylinder transmits equal retarding force to all the wheels of the vehicle and hence prevent the vehicle from skidding. It is not like the front wheel will be getting more force, the back wheel will be getting less force, or vice versa. Equal amount of force is transmitted because of Pascal's law, and hence the vehicle will come to rest without any skidding. The next advantage is a small force is applied to the brake pedal exerts a large force to the wheel drums, which means when you are comparing the cross-sectional area of the master cylinder with the wheel cylinder is having more surface area. So, and as a result, what happens? A small amount of force applied to the master cylinder creates a large impact on the wheel cylinder, or large force in the wheel cylinder. Hence, it is very easy for the driver to maintain or to adjust its speed and apply brake. I hope this video is clear to you. Thank you.